So we're going to solve for x from framework 6 here, using sine, cosine, maybe even tangent. So what we've got going on here is we have an angle of 57 degrees. This side is the adjacent side because it's next to the angle. It's between the right angle and the given angle. And then this is the hypotenuse. So for trigonometry, you got to remember SOHCAHTOA. So here we have a and h, which means we could write a cosine equation. That would equal a over h. And then you're trying to solve for x. So you would multiply by x and then divide by cosine 57. So we'd have x equals 34 over cosine 57. That's one of them. We could also figure out what the other angle is. 90 plus this angle plus 57 has to equal 180. That means this angle needs to be 33. We could do another equation that involves 33 degrees, but that would be sine, so that we would have opposite and hypotenuse. So it's the exact same thing, but we're going to replace the cosine 57 with sine 33. We have the exact same equation, except with a sine 33, which is option B right there. To approach a runway, a small plane descends at a 5-degree angle of depression. That means this angle right here is 5 degrees. Angle of depression is also the same as the angle of elevation from the other side, so this is also 5 degrees. And it's starting at a height of 1725. So we need to figure out to the nearest tenth of a foot how many feet from the runway is the airplane. So here's the airplane, there's the runway, that's what we're looking for, the hypotenuse right there. So that's the hypotenuse. We know this side, which is opposite the 5-degree angle. We have opposite and hypotenuse. We're doing a sine equation. Sine of 5 degrees equals opposite over hypotenuse. So cross multiply, we get x times sine of 5. Now we'll divide by sine of 5. So on your calculator, you'll get sine of 5 degrees. It'll be about 0.087. So if you did the whole thing, 1725 divided by that sine of 5 degrees, you get 19,792.2 D. So here we have a bacteria density from framework 8. Density is always mass or population divided by volume or area. So density equals population divided by area. The population is 3 million. And the area is 5. we get 600,000 bacteria per square inch. In scientific notation, if you were to want to write it in scientific notation, you'd have to move the decimal 5 places, so that would be 6.0 times 10 to the 5th. Trying to find the height of a mountain, he knows how far away he's standing. He estimates the angle of elevation to be 43 degrees, then uses tangent to find the height of the mountain. If his angle of elevation is off by 1 degree, so if it was 44 degrees or 42 degrees, what would be the change caused by the small difference in the angle measure? So if we had a quick little picture drawn out here, we know that we're 0.25 miles, which means 0.25 times 5280 feet. So he's standing 1,320 feet away from the mountain. 0.25 times 5280. We're trying to estimate the height if it was a 43-degree angle. So that would be tangent of 43 degrees equals opposite over hypotenuse, x over, or opposite over adjacent, I mean, x over 1320. To do tangent of 43, 1 times 1320, and you get the height is to be about 1,230.919, so you could round that up to 31. It says round your answer to the nearest foot. Then we need to see what that would be if we used a 42-degree angle and a 44-degree angle. So if he was off by 1 degree and it was supposed to be 42 degrees, you do the exact same thing. You get 1188.5, we'll round up to 89. And if we did it with the 44-degree angle, so I wrote the wrong number down there. Ran up to 1,275 feet. So it asks what the difference would be in the mountain's height. So 1189 subtracted from 1231. 1231 minus 1189 gives us a difference of 42 feet. And if we did the other one, 1275 minus 13, or 1231, 1275 minus 1231, that's a difference of 44 feet. So those are the two differences, 44 feet, 42 feet. Here we have a ramp going up to the back of a truck. It says that it's 30 inches above the ground, so that's 30 inches. The length of the ramp is 72 inches. What is the measure of the angle the ramp makes with the ground. So we're trying to find this angle right here. So we have a right angle. We're looking for that. This is 72 and the height over there is 30. So to find that, we have opposite and hypotenuse. So that's a sine equation. Opposite over hypotenuse. And then since we're trying to solve for the angle, we have to do a inverse sine with 30 over 72. To do that, you normally have to push shift or second, depending on the type of calculator, before you push sine. And then you type in your fraction, 30 over 72. 30 divided by 72 in the parentheses. You get about 24.624. So to the nearest degree, that would be 25. Find the exact length of the arc. So here's our arc. That is 1/4 of a circle. You see it's a quarter of the circle. So it's 1/4 of the circle, which means the arc length is 1/4 of the circumference. And you find the circumference by doing 2 times pi times radius. 2 times pi times the radius, which is 8. We use 3.14 for pi, multiply that out, and you get, well, nope, we're not going to use 3.14 for pi, because pi is in all those answers. So just keep the pi. And you end up 8 times 2 is 16, times 1/4 is 4. So you end up getting just 4 times pi, which is B. If you use 3.14, you then have to use 3.14 for all the answers to see which one's the right one. Cylinder shown is made of concrete and has a mass of 339,292 pounds. Find the density of the concrete. Density equals mass divided by volume. So we know the mass. We need to divide by the volume after we find the volume. This is a cylinder, so it's pi times radius squared times height. The height is 36. The radius is 8, half of 16, 8. And we'll use 3.14 for pi this time. So the volume of this cylinder is 7234.56. Kind of funny, 2, 3, 4, 5, 6. So that's what we divide by. $339,292 divided by 7234.56. You get the density, 46.9 pounds per cubic foot. What transformations are necessary to map a circle with center 5, -1, and a diameter of 6? So we know the center. We want to know the radius. The diameter is 6, the radius is 3. And then for this other equation, we need to know the center. So you change the signs on here. So this is a +2 and a -4. That's our center. And the radius, that's r², so the radius is 6. These scale factors are wrong. That should be a 2. And that should be a 2. So these have a scale factor of 2. To get from a radius of 3 to a radius of 6, scale factor is 2. And then to move it from 5 to 2, that's going 3 to the left, and subtracting 3. 5 to 2 subtracts 3. And then from -1 to -4, that also subtracts 3. Let's see. Determine x such that x comma 6 is on the circle with center 2, -2, and a radius of 10. So what we're going to do is we're going to plug in this for x and 6 for y into the equation of the circle, which would be x minus 2 squared plus y minus -2 squared equals radius squared. So 10 squared is 100. We plug 6 in there for y. So that's x minus 2 squared plus, that ends up being 8 squared, which is 64. Subtract the 64 to get 36. Then to get rid of that squared, we're going to do the square root, which means we have x minus 2 equals the square root of 36, but it actually equals, we know the square root of 36 is 6, but it could be 6 or it could be -6. Always plus or minus when you do a square root. So it could be +6 or -6. That's why we get 2 answers. So add the 2 over. Mistakes here again. Add the 2 over, we get 8. Add the 2 over, you get -4. So +8 and a -4. Here we have a quadrilateral inscribed in a circle, which means that the angles that are across from each other always have to add to 180. So if this angle is 28, this angle over here, angle D, would be 180 minus 28, which is 152 degrees. Here we have a circle inscribed in a triangle, which means these are all tangent segments, and any 2 tangent segments to the same point are congruent. So if this side's 7.6, so is that. If this side's 13.3, so is this piece. Then a little subtraction to figure out the other half, the other part of this side is 22.7. 36 minus 13.3. And if that's 22.7, so is this. It asks for the perimeter, so you just add all that up. You get 87.2. That's feet. Here we have a circle with a radius of 39, and then the distance from the center to the chord is 15. Find the length of the chord. So first we can do Pythagorean Theorem to figure out what this side is. X squared plus 15 squared equals 39 squared. So that's x squared plus 225 equals 1521. So x squared equals 1296. Which means x equals 36. But that's only from this, that's only for that piece of the chord. There's a theorem that told us that a right angle, when the radius intersects a chord with a right angle, it bisects it, it cuts it in half. So these are both x, so that's 36, and that's 36. So the whole thing is 72. So here we have general conic form. We want to know the radius, which means we need to complete the square a couple of times. So you first do x squared, then the x plus blank, and then the y squared minus 6y plus blank equals, move that 9 over to get negative 9. And we fill in the blanks with b over 2 squared. So 8 over 2 is 4, squared is 16. So we add 16 and 16. So this was going to be x plus 4 squared. Here we fill in the blank, same thing. Negative 6 over 2 is negative 3 squared. We get 9. Add 9, add 9. And that would factor to be y minus 3 squared. Add all that up, you get 16, which means the radius is the square root of 16, which is 4. We've got two congruent cones with a radii, each with a radii of 14 feet. So if you just had one cone, if you just focus on the one, the radius is 14. And it's a cone, so it comes up here to a point. The height, so it's the total length of them together, which is, the two of them is 24, which means the height of one of them is half of that, which would be 12. So we have a cone, the radius is 14, the height is 12. Volume of a cone is pi r squared times h, and it's a cone, so it's times a third or divided by 3. We're going to plug in 14 for r and 12 for h. Which is 3.14 for pi. And then since it's a cone, you divide by 3. So that's the volume of one cone. There's two of them together, so you have to double it to get 4923.52. That was all in feet, so this is feet cubed, cubic feet. We've done a lot of bisecting of segments. We know that you have to stretch the compass more than halfway. Here we have a pyramid, and it says it's split into a 1:4 ratio. So we've got 1 above and 4 down below, which means the entire pyramid is divided into 5 sections. 1 plus 4 is 5. So that means that this cross section here, which will be the same as the base, so we have a pentagon on the base, we have a pentagon for the cross section. The side length of every side is going to be, since there's 5 pieces, it's going to be 1/5. So if that's a 25, the side length is going to be 5 for the other one. So since the top pyramid is 1/5 of the entire pyramid, you just divide the base by 5. 25 divided by 5 is 5. Angle side angle states that if two triangles are congruent if, how many angles? There's 2. Angle, there's 2 of them. 2 angles and the included side are congruent to 2 angles and the included side of the other triangle. So for 48, it's just a basic sine and cosine question. So from angle A over here, we'll start with that. This is opposite, adjacent, and hypotenuse. So if we were doing sine of A, that would be 28 over 35. Sine of A, 28 over 35. Which is 0.8, which would be 4 over 5 if you reduce it. So that's not it. Cosine of A would be 21 over 35, which you can reduce to 3/5, which is exactly what we're looking for. Sine of C, so now we switch, we do this angle. So this is now opposite. This side would be adjacent, and there's the hypotenuse. Sine would be opposite over hypotenuse, 21 over 35. That one's good. Cosine would be the 28 over 35, which is not the right one. So you also should remember that sine of one angle is going to equal cosine of the other. You can see that sine of A is the same as cosine of C, and vice versa for sine of C and cosine A. So there's always going to be paired up like that. Sine of one angle will equal cosine of the other. So it won't be like sine of A and cosine of A. That wouldn't make any sense.